Hey guys, it's Miss Johnson, and I'm here to bring you the second part of our Unit 2 Notes 4. We just have those last three questions to finish up on Notes 4, the word problems at the bottom. And so we are starting on the bottom, the last page, the third page of your Unit 2 Notes 4. So flip to number 7, please. It says, in number 7, Dante spent $11.25 on 3 new and 4 old comic books. Samantha spent $15.75 on 10 old and 3 new comic books. Write a system of two equations that represents the amount of money each person spent on comic books. How much does each type of comic book cost? So we need to start by writing a system for this. So we are going to think about the things that we want to find. The question at the end says, how much does each type of comic book cost? So those are the things that I'm finding. I'm going to say that X is the price of new comic books, and that Y is the price of old comic books. Okay, so now there are two people who bought comic books. We have Dante and we have Samantha. So if I write an equation for Dante, Dante spent bought 3 new comic books, so that's 3 times X, and 4 old comic books, so plus 4 times Y. So 3X plus 4Y, and that was equal to $11.25. Then for Samantha, Samantha spent or bought 10 old comic books. Now be very careful here. They switched the order of how they read them to you. So the 10 old goes with Y, and the 3 new goes with X. So that's 3X plus 10Y is equal to 1575. Okay, so there is the system that I need to solve. It's set up very nicely for elimination. My X terms are lined up, my Y terms are lined up, the equal signs are lined up, the constants are lined up. So all of those things are really helpful for me to be able to eliminate to use elimination to solve the system. So that's what I'm going to do. Now, the first thing that my eye is drawn towards is the fact that I have the same coefficient for the x terms. I have both x terms with a coefficient of 3. So that's really helpful because all I really need to do here is make one of these two things negative. So that's what I'm going to do. I'm going to multiply this top equation by -1. And remember that when we multiply an equation, we distribute it across the whole thing, all 3 parts, the x term, the y term, and the constant on the other side. That's what keeps our equation equal, or the same. So when I rewrite this new equation, I have -3x minus 4y is equal to -$11.25. Okay, now this equation I'm going to keep the same, this one that's right here. So really it's kind of like that's the new system that I'm solving. Now I'm going to add these together. Oh, that was a horrible line. Let's redraw that. Add these together. There we go. And when I do that, what happens is my x terms drop out, which is what I wanted. And then I have 10y minus 4y, which is 6y. And I have 1575 minus 1125, which is $4.50. So I have 6y is equal to 4.5. And then I need to divide both sides by 6, and that will give me my y value. So y is equal to 0.75 after you type that into your calculator. Now I need to plug that back in to find x. It does not matter which one of these equations you pick. I'll just pick the top one. That means I have 3x plus 4 times 0.75 is equal to 11.25. That's 3x plus 3. When you type that into your calculator, 4 times 0.75 is 3, is equal to 11.25. Subtract the 3 from both sides. That's 3x is equal to 8.25. And then divide both sides by 3. So I end up with x is equal to 2.75. So now I can write out an answer to that question. I know that new comic books cost $2.75. And I know that old comic books cost 75 cents. And that is my answer to the question. So let's take a look at number 8. In number 8, it says Amy is walking a straight path that can be represented by the equation -2x plus y is equal to 3. At the same time, Kendra is walking the straight path that has the equation 3y equals 6x plus 6. At what point will the two girls be in the same place? So basically you want to know, where do these two equations cross, or where's their point of intersection, or in other words, what's their solution? So you have a lot of ways that you could solve this. We could use substitution, we could graph the two equations and see where they go, or we could use elimination. If I look at the two equations that I have, negative 2x plus y equals 3 and 3y equals 6x plus 6. There's a couple of things that I notice. One, none of the variables are alone, so it's not super easy to use substitution right now as it is, but I could very easily either add this 2x over and use substitution, or subtract this 6x back and use elimination. I'm going to choose to change the bottom equation and leave the top equation the same. So I'm going to subtract 6x, and that leaves me with negative 6x plus 3y is equal to 6, and negative 2x plus y is equal to 3. Okay, so the top equation I kept the same, I just rewrote it down below. So now the next thing is I need opposite coefficients. Now the negative 2 and negative 6 are not opposites, and the 3 and 1 are not opposites, but I can very easily multiply this bottom equation by negative 3, and that's going to give me a negative 3y, which will cancel my positive 3y. So if I do that, remember to go all the way across, even on the other side of the equal sign. My top equation is going to stay the same. Negative 6x plus 3y is equal to 6. And the bottom equation is now going to look like positive 6x minus 3y is equal to negative 9. Now I have opposite coefficients, now I add them together. But take a look at what happens when we add them together. When we add them together, negative 6x plus 6x is 0. Positive 3y and negative 3y is also 0. So I've knocked out both variable terms on the left-hand side here, meaning I have nothing left over. We represent nothing with 0, so there it is. Let's take a look at the right. On the right, I have 6 minus 9, which is negative 3. Now, this is one of those situations where we have to ask ourselves, are we left with a true statement or are we left with a false statement? In this case, 0 does not equal negative 3. This is a false statement. So what that means is that there is no solution. Now, let's talk about what that means in the context of our problem. We were talking about where the two girls, Kendra and Amy, were going to cross paths. If there is no solution to the system of their equations, then the true answer is their paths will never cross. So there's lots of ways you can write out that phrase and get the same message across. Let's talk about the last one, number 9. It says a shipment of TVs, some weighing 30 pounds each and others weighing 50 pounds each, has a total of 880 pounds. If there are 20 TVs altogether, how much of each type of TV are there? Okay, so how much of each type of TV? How many of each type of TV? So we have 30-pound TVs and we have 50-pound TVs. I need to give those variables. So I'm going to say X is the 30-pound TVs and Y is the 50-pound TVs. So now let's write out a system. There's a couple of things going on. There's one that talks about the weight. One equation is going to reference the weight of the TVs, and the other equation is just going to represent the number of TVs that exist. So we know there are 20 TVs altogether, so that means that the number of 30-pound TVs plus the number of 50-pound TVs is equal to 20. Now, if I write an equation for the weight, I know that 30 times every 30-pound TV plus 50 times every 50-pound TV is going to equal the total weight of the shipment, which is 880 pounds. That's the system I'm going to use to solve. Okay, so the next thing I want to do is I want to set it up so that I can eliminate one of the variables. This top equation is going to be really helpful for me because these two variables have a coefficient of 1. So I know that I can very easily cancel them. I'm going to take this top equation and I'm going to multiply it by negative 30. And don't forget that goes all the way across to all three parts. So I have negative 30x minus 30y equals negative 600. The bottom equation I'm going to leave the same, so I'm done with that one. Let's put those bottom two equations together. When I do that, 30x minus 30x is 0. Those drop out. Then 50y minus 30y is 20y, and 880 minus 600 is 280. Then I need to divide both sides by 20, and that gives me y value of 14. All right, so now let's plug that back in and get the x value. I'm just going to use this original top equation and say that x plus 14 is equal to 20. Subtract the 14, and I have x is equal to 6. So what that tells me is that there are 6 30-pound TVs, and there are 14 50-pound TVs. That is the answer to that question. All right, that's going to conclude our notes for Unit 2, Notes 4. So make sure you check your note sheet off with Ms. Johnson and pick up your practice sheet, and we'll move on from there. Thanks for listening.